podcast.
Yes, verily.
All right. Welcome to Hacking the Grepson, where I try to think of funny intros that will surprise Matt so that he doesn't know how to respond. Yes, I'm Mike. I'm here with Matt, and this is a programming development podcast. Thank you to who is listening. Also go to Zombocom. The impossible is unimaginable at Zombocom. Today, I thought, because of this blog post article that I read on the Internewts called CSVs Are Kinda Bad, DSVs Are Kinda Good. This is an episode about data formats. I think we should do like an overview of what we mean by data formats and kind of talk about, what that means in technology and programming.
I think a disclaimer is also worth. We are going to be talking about data formats, so folks, if you are prone to excitement, please be sure that you're sitting during this podcast.
Yeah, it's gonna get heady up ends. Just saying. All right. But I would like to dive like a little bit deeper just into what this article is talking about, which are CSVs, because they're a pretty popular data format, but they've gotten a bad rap over the years, and this guy is trying to talk about possibly doing it a different way, but that also has its own issues. So, but first of all, Matt, when I say data formats on a scale of 0 to 10, how excited are you?
Sorry, what? I fell asleep after you said data formats. Actually, I'm saying that, but honestly,
it's a 10, right?
It's something
like
I do
12.
think about. It's not a 10, but like it is definitely something that is an absolute necessity for folks in our positions to have to know and think about. And I do have opinions about various data formats. I don't know, 5.
Okay, I'll take a 5. I was going to say 10,000, but 5 is good.
That's over 9,000.
It is. It's quite a bit over 9,000. But like, if I say data formats, like, what's the first data format you think of when I say data format? Just boom, hit it.
XML.
Oh man,
I don't know why I let my mind go blank, and that's what floated in.
Because
I know why.
Okay, well, I started making a list of all the data formats I could think of, and I came up with, I don't know, a dozen. None of those were XML. One of them is a form of XML, so I guess sort of. But why did you think of XML?
Because I was learning about SVGs the other day and scaled vector graphics, and apparently those are written entirely in XML.
Yes.
I didn't know that. And
unfortunately.
I was like, And that tab happens to be open, so that's probably why that was the first one that popped into my head.
So, just to contextualize this, when you're using computers and you're programming and you're developing, both the stuff you're writing your programs in is a data format, but also you're most likely taking some kind of input and making some kind of output, and generally those also take the form of data formats. And I would think, maybe you might disagree, but I feel like all of the inputs and outputs that our programs generally take that we write, can generally be put into 2 buckets, plain text and binary.
Yeah.
Obviously, within those, there's many different sub formats of what that means. But like,
there's a third, which I would say is, I guess it looks like plain text, but it is encoded in some way, like base 64 encoding something. That is a data format, and it looks like it's a way of representing binary data in plain text in ASCII.
right.
But basically, yeah.
Oh, I get it. Base 64ically, even.
Wow. That was not the pun I was going for, but I like it.
I did it. So when I think of data formats, here's some of the ones that I came up with off the top of my head. I put them in the category of plain text, which are ones that, humans can read and write. Just text. Literally just ASCII characters in a file using, the ASCII set of characters that are acceptable. Since I'm a web dev, I look at HTML and CSS and JavaScript, or maybe TypeScript all day. Those are all also plain text. JSON JavaScript object notation.
That was a close second right behind XML in my brain. I said XML and my brain immediately went JSON.
Yeah, I feel like JSON has kind of become the standard of like data interchange on the internet, whereas XML used to be more.
It's like JSON, XML, YAML, and CSV.
TOML.
Honestly, those like all have been in competition with each other throughout the 20-something years of my. I think I need to start saying 30-something years of my of my career soon, which is kind of scary.
Yeah. So those are like plain text things, but then we have binary stuff, which if you try to look at it on a computer will generally be displayed as like gobbledygook, like a bunch of random.
That's a technical term.
Yeah, it will try to use random ASCII characters to show it to you, like if you look at it in a text editor or something like that, but it won't make any sense and it won't be readable or editable or anything like that because it's in a format that only the computer can understand.
Right. I would look at it in a hex editor, not a text editor, and I still wouldn't know what was in it because that's not going to tell you anything.
Right.
It's like, that binary is written in a way that I can now tell what bits are there. I still don't know what this code does.
Right. Well, although some data formats you can read with a hex editor and actually edit some. And the one I was going to bring up, because this is one I actually have semi-recent experience with, are Logic files. So the app I'm using right now, Logic, on a Mac to record this podcast, when I'm done recording, you get a Logic X format file, and that's because I'm using the container or bundle style, where it takes all the stuff that Logic uses, which is the file that says like how many tracks there are, a list of all the audio files, the actual audio files, meta info, all that kind of stuff. It's all in a bundle, which is very Mac like, because that's another format, which is the .app file, which is really just I think it's just a zip file that's been renamed so that you can just open it up and see what's inside. I
think it might even just be a straight up directory.
Is it?
I might be misremembering because it's been several years since I did any development in that space. But I remember, at the very least, just going into the package contents directory of various applications. At one point in time to set things up.
Yeah, that's what I had to do because I had this specific issue where I had a Logic file and it had notes in it, which is actually what I'm using right now to look at the list
Musical
of... Musical
notes or text notes?
Text notes.
Okay.
So I wanted... There were lyrics of a song, and the thing is that I wanted to be able to get the lyrics out of that field without having to open Logic, because opening Logic is kind of slow and cumbersome because it loads a bunch of stuff besides just this little field that has some text in it. And so I was like, oh, maybe I'll look in the Logic X file and see if it's in there somewhere. I had to use a hex editor, and then I had to find like the specific spot in the file where that ASCII text actually is readable, and write a script that would basically go from like the beginning marker and the end marker of it and grab that text and pull it out into something that I could read. And so now I can just run like a script and a file name, and it will spit out that information. But that information
that also means you could change the lyrics really easily. You're almost a hacker now.
I'm almost a hacker. Yes, I've almost hacked the Grepson. Almost.
Yes.
I mean, at the end of this podcast, when we get to the final episode, whenever that may be, I'm hoping we will finally hack the Grepson. I don't know what that looks like.
I've been building the Grepson this whole time so that we can hack it.
There you go. See, we're a team.
It's still very much in its... I've written a 1 and a 0 so far, and I haven't decided the order I want to put them in.
I mean...
But I'm going to get there. I'm going to get there.
You're so close.
Every 100 episodes we put out, I'll add another binary character.
Nice.
I started with 1, and then... Yeah.
I can't wait for the next digit. Is it going to be a 1 or a 0?
Spoilers.
So yeah, so there's that kind of stuff, but there's also like images, JPEGs, PNGs, bitmaps,
SVGs.
SVGs. Although SVGs are plain text. Like,
it turns out.
You can't open up a JPEG in a text editor and see something meaningful, but you can open up an SVG and edit it.
Yeah. A bitmap, incidentally, is one of those few things that I can open up in a hex editor and understand.
So you could actually go in there and like change some pixels without opening up the file?
Because I've had to do a lot of stuff in that realm in the past. One of my first ever tasks, like in my first job out of college, I ended up reverse engineering something that generated fonts on a very specific type of machine because that same format, which no one had any documentation about, needed to be used by the helicopter that we were writing software for. So I reverse engineered and it was effectively a bitmap. And then I wrote an Excel like macro that would like put it into an Excel sheet and like format it so you could actually see what it looked like. It's kind of fun. I don't know why I didn't just generate a bitmap off of it, but that's what I did.
I love how no matter what cool thing I might come up with, you can always come back with, yeah, well, then I did something that went on a helicopter.
To be fair, it never actually went on the helicopter.
Oh, well, don't say that.
But that wasn't my fault. My part of the job got done.
Right. It's the other people. So yeah, so there's image files, there's audio and video files like MP3s or MP4s or MOVs or AVIs. That, you know, I talked about the .app file that Mac uses for kind of turning like you said, a directory into an executable that you just double click on, because it's really just double clicking on that data format and searching through to actually find the binary like file that's executable by a computer. But it hides all that from you, so it looks like the .app file is the file you're actually hitting. But yeah, that could be compressed. If it's not compressed, I think there's other data formats like that use like a .zip file but renamed as something else, just so that, you know, it's more in line with the app that's using it, so it knows what it is. I mean, we're kind of dancing around like all of these things, these extensions. Like when you have a file on your computer.
These are all basically file formats. You know,
right.
There are data formats that exist outside of file formats as well, and we talked about a couple of them. But in general, yeah, the extension tells you how to parse. It doesn't tell you. It tells the computer what program to use to parse the data, and in theory, should inform the application how to parse said data.
Right, and depending on which OS you're using, I think it can be interpreted somewhat differently, whether it's on a Unix, Linux, or a Windows or a Mac. Like, they use extensions differently, because like I could rename something to not have an extension, but that doesn't actually change the file in itself. It's not like if I change a .jpeg to a .png, it magically converts it from a JPEG image to a PNG image. It's still like the file information, the headers, the data is still the other thing. I just changed it to look differently, but that's not how file formats work.
Right. That doesn't change the file format. It changes the name of the file, which informs your operating system what application to use to open the file. Nothing to do with the actual contents of the file. The contents of the file is where we get the actual data formats. Some other things that, in the vein of what you talked about, that are similar, like along lines of like zip files, you got tar files, and then you can gzip those. A tar is just basically a huge concatenation of files all together with specific delimiters. There's a word that's going to come up in a minute.
I didn't know that about tar files. That's very.
It's effectively
useful.
just a giant text file, unless you're tarring binaries, and then it's a giant binary file. And then you gzip it, and it compresses it, and then it's really binary. But there's also things like protocol buffers. Have you heard of those?
I'm not sure.
So protocol buffers are something I've used these here and there throughout the last, 10 years, 15 years of my career. I know them from Google. I don't know if they're the originators. I didn't bother to look this up. It's an exercise for the listener. But Google has this thing called gRPC, which is an RPC, a remote procedure call protocol. I can't think of a better word for it. Google's remote procedure call, gRPC, right? And it uses a data format called protocol buffers, which you define the buffers in like a language specification, like I think it's like an IDL file or something, that specifies what it will look like and then it effectively compiles all the like parsings. You can like generate all the parsing nonsense around it for different programming languages. So it's like there's a definition file, and then that becomes the thing that informs the actual data format that is the protocol buffers, which is more of like a binary thing, so it like compresses stuff. But it lets you effectively make structs.
I mean, that kind of sounds like this idea of a DSL, like a domain-specific language.
Talk about.
Yeah.
Those are my favorite things.
Well, go ahead. Well, yeah, because I first heard about those when I started doing Ruby. I don't know why, but those came up. But yeah, go ahead and explain what a DSL is.
A domain-specific language is a language or a data format, whatever you want to call it. It's really that's kind of two sides of the same coin there. A programming language and a data format. They're both just like, how do I interpret this file, right? Same deal. Or this chunk of code. A DSL, though, is something that is not like an open standard necessarily, right? Like something like JSON, XML, HTML. Like those are standards that everyone is writing to, and they're specific to what they're doing, but they're pretty open. Like they're not tied into any sort of business logic generally. A domain-specific language is going to tend to be something along the same lines as those things, but very customized for the task that it's doing. They're very bespoke or one-off. They're the kind of things. They're the programming equivalent of the like one-trick pony kitchen gadgets that Alton Brown always hated on Good Eats. They're the same thing as those, but I love them. They're really really useful. You have some programming languages like Lisp are like tailor-made for making domain-specific languages, DSLs, and I've found them very useful over my career. But that's mostly because I like writing code that generates other code. That's just something I find fun, and DSLs
very meta
tend to fall into that space.
It's weird if you search Google for an example of a domain-specific language. The first one that comes up is SQL.
It is.
Also CSS and HTML and LaTeX.
I mean, I guess technically speaking, those are domain-specific languages because they are targeted at that specific thing they're doing, but that thing is so broad that I feel like they don't count in that category anymore. It's I think generally when people talk about DSLs, they're talking about very specific, bespoke, customized languages that they wrote to handle something. But I mean, that's how all those things start.
That's a good that's a good way to put it. That like a lot of domain-specific languages, just come from something that, or it may start there and then become a standard. If you go to Wikipedia, they give stuff like GML, which is the scripting language used in Game Maker Studio, or CFML, Cold Fusion markup language, which is really just probably like HTML but specific to Cold Fusion.
I think any sort of like proprietary data format that's only really readable and writable by like one program. That's in my mind what a DSL is. It's not necessarily because, like I said, anything that is meant for a specific purpose is technically a DSL. But
there's definitely some semantics to bat around on that one. But besides the point is that these are all just different formats that data can take, that an application or website or whatever can, read and use and then possibly write out so that it can be imported again, input to itself again or to another instance of the application or a website somewhere. We mentioned JSON. I mean, that's kind of become like the standard data format for how do I ask another website to send me some information about something. And that's generally how it's going to send it to you.
Because it's easily parsed by a computer. Right. And it's relatively easy for a human to look at and understand.
Right. I feel like that's probably how data formats have changed over the years. Like in the beginning, it was, but before Web 2.0, when every website was trying to talk to every other website, the way that you did that was a lot harder and less fun to do using stuff like XML or SOAP to and then it's become now in 2024 JSON, which is very easily readable by humans, but also readable by computers, and so you kind of get the best of both worlds.
Yeah, and I think the big thing with data formats, just to kind of put a bow on this, is it's kind of how you started it. It's, one thing is writing it, and another thing, or maybe even the same thing, is reading it later. And it's how do we make sure that both things are speaking the same language, and that's the data format, right? It's like a language.
Yeah. Well, and also, to get even more basic about this, it's like, why do you even need these files written in specific formats? Because you're not always running the program or the website at all times, and you need a way to I think the term is like serialize the data that the program or website needs to run and do its thing in a way that can be saved for later, so that it can then be pulled back in. Or, if you want to start something with information already existing, so you don't have to start from like a default scratch, you have to have some kind of data, and it has to be written in a format that can be read by the program and written out. But now my question is, which maybe is going to blow this thing wide open, is why do we have so many different formats? Like, why isn't everything just written in like 2 or 3 formats? Why do we have like hundreds of formats?
There's an XKCD comic where they talk about standards. And I think they specifically, maybe you're talking about like headphone jacks or USB. I don't remember the specific thing. But basically it's like, they're like, all these standards are stupid. They all do something wrong. They should work like this. And now we have N+1 standards. And that always happens, right? You're never going to have a perfect thing. Everyone thinks that not everyone. Many people think that they can do better than what's already there. I am one of those people that tends to, like, my instinct is, I'm like, this is stupid, I'm going to fix it. And that doesn't always work. And, sometimes you got things like JavaScript that someone cobbled together in a few days because they had to. They're like, I need something that can do this. Okay. Now I have it. And now we're stuck with it forever later, and it's awful.
Yeah. I think that's a good way to put it, is that we keep making more formats because we keep striving for the perfect format, which doesn't exist. And people keep getting born and having new ideas and think that they can do it better, and here we go into infinity.
Take something as simple as JSON, right? JSON's a fairly straightforward language. It doesn't do a whole lot. Like the syntax of it is fairly simple, and so which one of the reasons it gets used a lot. But it doesn't let you do, for example, comments.
I was just going to say that. Although you can hack it in there.
And it doesn't do a good job of allowing you to like set up the schema for it if you want to. So there are formats that let you do that. There's like JSON-C, which is JSON with comments. And there's, I think, JSON-5 and some other ones. And it's like, okay, so that's another place where it's like, all right, I love this thing, but it's missing this one feature. So I'm going to add this feature. And just, so it's like a superset of the original data format. TypeScript actually is that for JavaScript, technically. And then either that gets incorporated into the original standard, or more often it doesn't, and it bifurcates, and then it never gets reincorporated, and now you have you got 5 formats instead of 1.
And I can't believe we didn't even mention it, but Markdown.
Oh, I love Markdown.
I love Markdown too, but which Markdown, Matt? Because it has been, so many people have done exactly what you just said to Jason to Markdown. Because, it's just missing this. What flavor of Markdown is it, et cetera, et cetera.
Yeah.
It's we'll probably just keep making new data formats, even though we have plenty of perfectly good ones. And that leads me to the blog post that I wanted to talk about, at least for a little bit.
Oh, before you do that.
Yes.
We should talk about the most important data format of all, DNA. Nature's data format. We don't actually have to talk about it. I just wanted to mention it.
Yeah. Thank you for that. We would have been remiss if we hadn't said that.
Yeah.
But now to
Let's talk about the article.
But now let's sidestep DNA and talk about CSVs. So CSVs, that stands for comma separated values. What that basically means is like, oh, I want to have some kind of structured data and I want to be able to send it somewhere, like export it from a spreadsheet, perhaps, or import it into a spreadsheet, perhaps. And it needs, basically the spreadsheet needs to know where values end so that it knows what to put in A1 versus A2, et cetera, et cetera. And there's a lot of potential characters you could use to separate your values, like commas or tabs or spaces or
Those are like the three most common delimiters.
Right. Or you could use an obscure unprintable ASCII code,
That's ridiculous.
Which is what this article is talking about. Matt Hodges, thank you for your article. I actually really enjoyed reading your writing style. He proposes this thing called DSVs, which is delimiter separated values, which is kind of like let's not make this data format rely on a specific ASCII character that's printable, that's common, that can be in the values that you're separating it with. Let's instead use this ASCII code that's just a generic delimiter. Now
we've said the word delimiter several times. I feel like we should probably define it for people who have not heard this term before. It's just a character, or honestly, it could be a sequence of characters. But it's something that marks the beginning or end of a chunk of data, like a unit of data. So it could be a comma in the CSV. It could be a new line. That's very common in like plain text formats, etc.
Yeah, like pretty much many programs use plain text config files, like for example Apache, and it knows when one line is done and to move on to the next one because you have a new line character at the end. Whereas CSVs they don't use that. They just use commas to delimit, i.e. separate their values. So this guy basically wants to use this unprintable ASCII character that has apparently existed since ASCII has existed, but just nobody knows about it. Nobody uses it for various reasons. I don't know.
As long as it's less than number 127, yeah, it's probably there from the beginning.
He mentions four of them, 28, 29, 30, and 31, which are respectively the file separator, the group separator, the record separator, and the unit separator. And apparently someone used these things at some point back in the day, but now nobody does, and everybody uses commas. I don't know. What's your...
I feel like back in the early word processing days, before there was more standardized things like Word Perfect and Word, and probably some other thing that had the word in it. That was where, literally just you would write to the screen and there would be an interpretation of those characters, and it would know how to like print it out to the screen. And so it was, the file was just a concatenation of those things. And then those became, things like carriage return or line feed. Those tended to get turned into other things over time. But anyway, it's not relevant.
Well, but I'm curious. What's your gut feeling about using something like unprintable ASCII characters that have existed for decades rather than commas or tabs or whatnot?
It depends what you're trying to do, honestly. For straight up like CSV, like the specific suggestion that he puts in here solves a lot of problems. The one problem it won't solve is what if you put the delimited value inside of the piece of data, right? Like if I have a whole unit of data, and in that I need to, for some reason, represent that non-printable delimited character. Maybe I'm sending across a file that explains what another file has in it, right? If I have an Excel spreadsheet that I'm putting together in their DSV format here, and I want to explain what the different delimiters are, one of those is going to be this delimiter. Nothing ever solves that. You always have to have an escape. But the good thing about using something weird like this, or like Control G, which was the bell back in the day. Please don't use that as a delimiter. My old days of being a Unix sysadmin hurt me when I think about that. The good thing about using the non-printable character is it's unlikely that it's going to be in there. Most things you're going to communicate don't need it. Whereas if you use something like quotes, quotation marks are often going to be used in something. Spaces are almost always used. On the other hand, it's hard to read. Right? Like if you were to just print it out, you'd be like, I don't know what's this garbage character right here. Or you wouldn't see it at all, and it would just look like it's smushed together.
Yeah, I mean, I think my gut why this is not used and hasn't been used, and instead we use commas or tabs. Well, specifically commas is that you can see the comma, and you can if it blows up, you can at least see where it's blowing up. But if you have an unprintable weird garbage character, maybe it's just murkier to debug. Yeah.
Finding a character that is not used by the data that you're going to be shipping around is not always straightforward. I've worked at companies where we use the tilde a lot because it wasn't used in like any of the information that we needed to pass around. So it became the format or the delimiter until we needed to use that for something else. And then I think that was actually a specific instance of us shipping a config file or a license that had another copy inside of it for reasons. And then it's like, okay, well, how do we delimit that? And that's always a pain.
Yeah, well, I mean, you seem to be getting at the point is that any kind of data format that has the ability to be self-referential and contain itself in some kind of descriptive manner is going to have an issue no matter what character you choose to delimit one chunk from another chunk. So you, like you said, you always have to have some kind of escape character that says, okay, no, I don't mean that character. I mean the visual representation of that character, not the control version of that character.
I think the actual problem is trying to use a single character as a delimiter. Like using that instead of like a key combination, which is actually the good thing about what he's doing here with the like file separator or whatever. It's more of like a sequence. You're less likely to have that in there. But in general, I would just, I tend to use regular expressions for parsing things or tokenizing them. And that's a whole other podcast right there. But that lets you, that works around that, right? Then you can say, okay, I want from the beginning of the quote to the end of the quote, and I don't care what's inside as long as it doesn't match, if it matches this criteria, blah, blah, blah. You can just lay out all the rules, and then you don't have to worry about those things. But a comma is so much simpler.
Yeah, and simple often beats complicated, which, and I just want to read the last two paragraphs of his blog post because I think they sum this up pretty well. So he goes through this whole thing talking about his idea of using this unprintable ASCII code, but then there's issues. And then he says, and all this is to say that the major downside is we have decades of tools built around handling the weirdness of CSVs, but not so many tools built around using the delimiters the creators of ASCII gave us. And so depending on what you're doing, it might be easier to just use the tools we have. But sometimes you're writing software that produces data on one side and consumes data on the other side. And sometimes that data comes from users who are hostile, intoxicated, or both. And you just want to pass that around and not think about it. And maybe the beauty of a standard from the 1960s is a better choice. Data!
Little Johnny drop tables. That's what that makes me think of. To reference another XKCD comic.
Well, because there's always a relevant one. And he just keeps making more, so there's just constantly going to be more relevant ones. Yeah, so I brought this up just because, like I said, I enjoyed reading it. I thought it was an interesting idea. You brought up some good issues with it, and how much like this other podcast I was listening to that was all about striving for perfection, in that you will never probably have the perfect data format, which is why we have so many of them. But it doesn't mean you should stop striving and improving, because that's the drive that keeps making things better, even if it's not perfect and we don't eventually end up with, .file as the only data format to represent all kinds of data.
I have a series of sticky notes on my monitor to they're kind of like motivational poster type things, like sayings.
Okay.
But they're more to keep me on track when I start to like fall into the panic of, oh my God, software development is actually not super straightforward, and I want to do it perfectly. And one of them, the first one actually, is something my old boss used to say. Like, this is one of my first bosses, actually at the helicopter place.
Again.
And she used to say, aim for success, not perfection. And I love that because it gets you to the good enough solution. But then the other one I have on here, that's my own personal saying, is make it work, then make it work better. So I like get something that's good enough. But then, like you said, relentlessly strive to improve that thing. I like data formats that are versioned and improve over time because they've learned from their mistakes.
Yeah, I think that's a great way to put it. Also, just, for more context, you got to think about the history of computing and how computers were 40 years ago and how much processing power they had, how much hard drive space they had, what our networking capabilities were. A lot of the data formats that were written that we may still be using today were probably conceived of and created then.
Yeah, they had to work on a punch card.
Right. And so, they may not have been perfect, and they may, and you wouldn't want to still be using necessarily that data format from then. You want to be able to use the new technology and the improved stuff, which just means you're going to have more data formats that you have to learn about and figure out how to process.
Yeah. I think we should just all agree on a character that we will never, ever use for anything else, and that's the delimiter for everything from now on. And if you need to embed it, too bad. It has to be a reference to something else.
It is the delimiter who shall not be named.
Yes.
I think.
Full delimiter.
I think that, I think this was a bit of a Wild West style discussion of data formats. There's plenty you can learn about data and how it's formatted on Wikipedia, but hopefully our 20 plus years, almost 30, of experience with data formats has helped elucidate at least some of the ones that we deal with on a daily basis. Actually, before we go, what's your favorite data format? Or least favorite?
Gosh, that's actually a genuinely good question. I don't know if it's my favorite, but my most used thing is probably base 64, which is why I thought of it earlier.
Really? You use it that much?
I used to. I don't use it as much anymore, but it used to be I was frequently needing to ship binary information in the smallest possible format, but I couldn't do binary because it had to go over had to be a query string or something, so it had to be able to be in the URL.
Yeah.
Base 64. It's one of those things I need to encode some data and put it in a format that I can open up later and easily be able to read. But that's more of an encoding and not so much the format, because then inside of that is another format. In which case, I guess I got to go protocol buffers. That's my favorite.
Okay. I was just thinking how wild it was the first time I realized that you could embed an image on a web page, and you don't need to do source equal image.jpg. You could just do source equal base 64 string, and how wild it is that those two things can mean the same thing, even though they're seemingly completely different data formats. That's crazy, but not that crazy anymore. Okay, that's data formats. If you want to listen to more of our discussions about various things that are related to this or not related to this, you can find more of our episodes at hackingthegrepson.com. We try to put an episode out every other Wednesday. So far, I think we've hit that mark every time. So go us. And
go you, really. That's
well, go the internet. Thank the internet for this.
Go internet.
Go internet. I think that's safe. That's what my shirt says, I swear. But until then, we now return you to your regularly scheduled lives already in progress.